Welcome to the hands-on section. I'll just quickly run the uh, programs we saw in the slides over here. There's very little to explain. I reformatted the programs a little bit for readability. So for example, each string that is printed out to screen, all the elements of that are put on a single line in the source file now. So it makes it easier to read, easier to make sense of what the output is going to look like. So we have the is digit. In the first example, we test out the is digit, is alpha, is alnum, and is hex digit functions. So I'll run this. And there you go. So exactly what you saw in the slides. So 8 is a digit, hash is not a digit, A is a letter, B is lowercase b is a letter, and is not a letter, 4 is not a letter. For the is alnum function, capital A is a digit or letter, 8 is a digit or letter, hash is not a digit or letter. According to is hex digit, F is a hexadecimal digit, J is not, 7 is, $sign is not, lowercase f is a hexadecimal digit. Let me jump to the next program now. Okay, the next one is in which we try out the is lower, is upper, two lower, two upper functions. So we have is lower, couple of is lower function calls, couple of is upper function calls, and I'll just run this right away because I think we're short on time. Okay, so lowercase p is a lowercase letter, capital P is not, 5 is not a lowercase letter, exclamation is not a lowercase letter, D, capital D is an uppercase, lower d is not an uppercase, 8 is not an uppercase, dollar is not an uppercase. And then we do the conversion functions. So U converted to uppercase is capital U. 7 converted to uppercase is just a 7 again. Dollar converted to uppercase is still just a $sign. Uppercase L converted to lowercase is small l. So this works exactly as advertised, exactly as it should. And now let me jump to the next one. And this is the one in which we test out the is space function, is control, is punctuation, is print, and is graph. Run this. So this code is completely unmodified. Like I said, I just formatted, I just put the line breaks in where it made more sense to me. So according to is space, new line is a white space, horizontal tab is a white space, percentage is not a white space character. Is control, new line is a controlled character, dollar is not. Is punctuation, semicolon, yes. Is capital Y is not a punctuation character, hash is a punctuation character. Is print, dollar is a printing character, alert is not a printing character, you don't see that. According to is graph, Q is a printing character, space is not according to is graph. Now let's try the string to double function. So this is the one where we had this 51.2% are admitted string, and we call the string to D function, pass it that string as the first argument and a character pointer as a second argument, and then when we come out of that, we print out first the original string, the whole string, and then we print out the number that we were able to convert to D using string to D, and we print that out up to 2 decimal digits as a floating point number, as a fraction, and we print out the remainder of the string that string to D was not able to make sense of when it was converting to a number. So that should be percentage are admitted. And here you go. So string is 51.2% admitted, the original string. The converted number is 51.20 because we print it out here as a 2 decimal digit number, and the remaining string is percentage are admitted. So this part over here, the part that is not numeric and comes after the number. Now let's try out. We did 6 examples today in the lecture. So string to L, string to long integer. Similar example. In this one we have a negative. The string contains kind of the start of a negative number, and then that is followed up by 3 letters A, B, C. Example is very similar. I'll run it right away. So original string, this whole thing, numbers ABC. The converted value is -1, 2, 3, 4, 5, 6, 7. The remainder of the original string is ABC. And the converted value plus 567, so this is us doing some math, is -1,235,000. And that brings us to the last example, in which we convert to an unsigned long integer. And in this one we just take away the negative sign over here. Similar setup, and let's run this for you. So we do the same thing, print the original string, print out the value returned by the string to unsigned long function, the number that we were able to recognize as a number, 1,234,567. The remainder of the original string is ABC, the last 3 trailing letters, and then we do some math by subtracting 567 from this number, and we get 1,234,000 again. And that's it. That's the hands-on section for this, and in the next section.